We address the problem of synthesizing navigation abstractions for planning with portable manipulation skills and demonstrate our approach on a mobile manipulator platform, Spot. As input to our approach, the robot must first navigate around an environment and build a semantic map of that environment. Using off-the-shelf localization and mapping techniques and pre-trained visual models, the robot can build a semantic map that includes a 3D scene geometries of the environment, as well as object information including what objects are in the scene and their pose. Given that the robot has access to a set of portable manipulation skills, the robot can then generate a plan for how to manipulate the environment to achieve a goal. For example, the robot is specified with the task of making coffee. Using a symbolic representation of the problem that only models how the robot can manipulate the environment, the agent can plan a sequence of actions involving picking, placing, pouring, and manipulating articulated objects to achieve the goal. Now, using an action-oriented semantic map, or AOSM, the robot can synthesize the necessary navigation behaviors to successfully locomote the robot around the environment to support executing the manipulation behaviors. For example, the action-oriented semantic map enables the robot to sample a body pose, visualized here, for the pick-up water cup action, which it can then leverage a path planner to move to, and then subsequently sample a body pose for the pour water action, and use the path planner again to locomote to the next pose. The distribution over poses for the pour water action are similar enough to the place water cup action that the robot does not need to navigate to execute the action. This procedure repeats for the rest of the plan. The robot samples a pose for the pick up coffee grinds action, which it uses a path planner to navigate it to in order to afford executing the manipulation skill. The robot then does this for the pour coffee grinds action. Lastly, the robot samples a base pose for executing the closed lid behavior. And a pose to afford the push button behavior. Ultimately, this enables the robot to brew a pot of coffee. As a result of an action-oriented semantic map, a robot can build a symbolic representation of a new environment with known objects in just a few minutes, making learning task-level representations efficient enough to be practical in real tasks.